Welcome. My name is Matt Casters. I'm the Chief Architect of Data Integration at Pentaho. Pentaho Data Integration is also a project known as Kettle. It's been around for about 10 years now. I would like to thank DataStax for allowing us the opportunity to sponsor this event and to talk today. I want to keep this as action-packed as possible. There's a lot of you who haven't heard of Pentaho yet, so that's something I have to fix. So I'm going to talk about Pentaho, and then I'm going to talk about the concept that we launched last month, the concept of blended big data integration. And then I'm going to try to go into a demo as soon as possible, so to keep it a little bit less theoretical. There's going to be opportunity to ask questions afterwards, but please don't wait until the very last minute. If you have any urgent questions, just ask. Welcome. So Pentaho tries to come up with a mission that kind of encapsulates all the things that it does. Pentaho originally started out as a collection of 4 or 5 open source projects to do data integration, but also reporting, API server, data mining, OLAP. So all these projects got added over time. So we're now, 5 years later, we're trying to unify that whole stack of software into a platform, combining data integration and business intelligence and analytics. We are basing ourselves on open source models to keep up with the innovation. So all the big data stuff that I'm going to show you, like the Cassandra input and output connectors, they're all open source. They're out on github.com. So github.com/Pentaho, there's a lot of projects you will find, including the Pentaho Big Data plugin, to which you can all contribute or not. But we are a commercial company. We try to make money from selling subscriptions to support, and we also sell an extra thin layer of enterprise edition software on top of our open source software to help customers go in production faster, maintain their software. We've had components for Cassandra quite a long time actually. We have multiple customers now, actually joint customers with DataStax in production. And so what you will see, for example, is that between versions 4 and 5 of Pentaho Data Integration, you will see more and more functionality pop up, like SQL tree and other stuff. I'll talk about that later. So what we're trying to do is create an environment where, given the complexity of the big data landscape, any kind of data is reachable, accessible. Any kind of environment is be made possible, and any sort of analytics can be done. So with Pentaho 5, we tried to go there. I'm going to try to skip a couple of marketing slides here. So this is the typical Cassandra kind of use case where we have source systems. Let's call them Cassandra clusters. And so these source systems could be Cassandra, or your enterprise data store could be Cassandra. We're not saying which one you should pick. What we propose is that you use Pentaho Data Integration to move from one data silo to another. Pentaho Data Integration will provide, at the very least, data orchestration, so that you can have at least a visual, graphical user interface to keep track of what's going on, to keep track of when something goes right, but especially when something goes wrong, so that you can send off emails, SNMP traps, and that sort of thing. We have a whole orchestration toolkits to check for all sorts of things, to watch for files popping up, and to execute and to notify. And although you can't program virtual languages like Java or JavaScript, SQL, big scripts, and whatnot, we didn't require it. So the scripting and the programming languages we try to reserve for those special cases where you're doing something really specific, really special. Okay. We try to come up with a broad connectivity to all the major big data technologies. These are just focused on the big data technologies here. For example, the Hadoop landscape, we have obviously DataStax, Cloudera, Hortonworks, MapR, Amazon, Redshift. The list apparently grows with every release that we do. Not because we want to, but because companies simply pop up all over the place. At the same time, existing technologies like Oracle, MySQL, Postgres, and so forth don't go away. And we have also seen the popularity of analytical databases like Vertica, Netezza, Greenplum, and Vectorwise, and so forth increase over time. So we provide integration from and to those different data stores. And you can roll that data up in Cassandra or vice versa. So what if you wanted to do analytics on Cassandra? So here is the one approach that we're proposing. And it is to use PDI data services. This is a new concept for 5.0 that we're launching. And I will give you, during the demo, I will show you in detail how that works. I thought it might be fun to do that. Another option is to, isn't it all visible? Is to load at the bottom the Cassandra data into, let's call it a database with RDBMS or a classical data warehouse on which you can then run Pentaho Analytics or any other analytical tool through SQL typically. But since Cassandra doesn't really directly talk SQL, and most analytical tools do speak SQL, you kind of have like a disconnect between two worlds. So direct access through Cassandra has certain advantages. It's the same with all the big data stores. Is a classical model of copying everything into an enterprise data warehouse kind of falls apart if you need to copy, let's say, a petabyte of data. Why would you keep the petabyte over here and not over there? So you end up maybe putting it all in the data warehouse in the database anyway, when you actually wanted to have it in Cassandra for various reasons. So the best of both worlds is possible, right? But we're proposing to use something else. We want to go to these operational dashboards where we can mix real live data, operational data, with, for example, historical data. Right? And we can only do that by going live to, for example, the Cassandra cluster, or to Mongo, or to any of these other. There's a resurgence of popularity for all sorts of SQL layers on top of Hadoop, Impala, that sort of thing. And this is there's a drive and need to go to more operational data to deliver that to the end. So the monetization reason for that is is to provide more insights to the users, to the salespeople, to the to detect trends more quickly, to see live what's going on, reduce cost. So if you look at a picture like this, and again, I'm sorry about the low resolution of the beamer, it couldn't be helped. the classical enterprise data warehouse approach does allow you to analyze data. We offer a lot of tools inside of Pentaho Data Integration, PDI called, to populate that data. So you can take data from Cassandra, for example, on a daily basis, populate an aggregated data warehouse with historical data, so that you don't have to store the petabyte, but maybe a couple of gigabytes, right? But at the same time, we do see the need for that real-time data. So PDI can also deliver data directly to reports, dashboards, and so on. Sorry about the cough. This sort of data blending inside of the ETL tools, inside the data integration tools, is an interesting option in the sense that the technical people can tweak and prod and performance tune the technical side, while the end users can see what's going on, can see the data. And this combination seems to be working very well for us. One of the interesting things that Pentaho created, and again this is available in open source, is an adaptive big data layer. So one of the problems that our technical people have been wrestling with is the need to support so many different Hadoop and big data technologies out there. So even if you look at a single vendor like DataStax, Cloudera, for example, or MapR, going from one version to another, the underlying Java APIs, for example, change dramatically sometimes. They offer varying levels of support for varying features. That's making it sometimes very hard to switch from one stack to another. That's why Pentaho created the adaptive big data layer to help us. But again, this is open source technology, help anybody integrate better with all the varying APIs out there. So we have for 5.0 new integrations, and for example, Redshift and Palas Plug, new certifications on DataStax, Cassandra, Intelligent Works, Cloudera, MapR, Mongo. So come on in. So during the demo, I would like to talk a little bit more about, for those that don't know Pentaho Data Integration, what the design principles behind it were. Okay, 25 minutes, that should do it. The design principles, why we think it's a good engine to have at your disposal. So I'm going to switch over to my virtual machine. So Pentaho Data Integration 5 is downloadable from Pentaho.com, and it has a welcome screen. You know, we have all sorts of links in there, including getting started, documentation links, IRC channels, source code links, the CI servers of Pentaho are listed here, the blogs you can read, the books you can read, how to build your own plugins for our software. So I'm not going to go over these things too much. 20 minutes is not enough to do everything. You can split up the functionality of Pentaho Data Integration into two main categories. So we have the concept of jobs, which are used to do orchestration. And so in this case, we have a starting point always, and you know, this is running some script. I think it is, yeah, it's creating a key space, running some CQL, and Then we write to Cassandra, read from Cassandra, and clean up. This is a automated test to see if our Cassandra cluster is up and running. The green arrows mean that if everything goes okay, you can go to the next job entry, as we call it. If you have a red arrow, then something is wrong, and then you can send off an email or you change something and retry. Orchestration, workflow. And then we have transformations, like this one. This is a very simple example. I do apologize for the simplicity, but I think it helps. So the first icon is like a text file icon. It reads from sessions.txt. It generates a UUID for every record that it reads, and it sends the data off to the demo key space in the sessions database. If you double click on one of these icons, you will see that you can specify how that, or you can't see it. I apologize. You can see how that, what the layout is of the text file. You can specify all sorts of things related to the functionality of this thing. One of the interesting things to know about this environment is that when we're specifying which text file to read, which kind of random value to add as a UUID, we are working 100% with metadata. I would say join the club, but so we were working 100% with metadata. So if for example we would copy this, copy the clipboard, there you go, and we would paste this into a text file, you will get XML. Trust me on this. I can't see it to increase the font size. So we're purely designing these things from a metadata perspective. We're not generating any code at any given time. What we created is a sort of virtual machine engine that is capable of executing upon the tasks that we designed in our graphical user environment. That in turn allows us to set up engines for our transformations, as we call it, in virtually any kind of environment. So we have implementations, for example, for executing our transformation snippets in mappers and reducers and combiners in Hadoop. And we recently, a couple of weeks ago, we announced that we also have our steps, individual steps running in storm topologies, for example. So when you see me doing this locally in my little teeny-weeny virtual machine, please remember that these snippets, these transformations can scale out into virtually any kind of environment that supports Java. So scaling out is possible, but scaling up as well. So if you execute this transformation, for example, what we will see is that you will get kind of a graph up until 1,000 rows or something in this virtual machine. 1,000 rows a second that it's storing. And that obviously is some kind of limitation of Cassandra, of the service, of the API. But Cassandra scales very well. So we could say, okay, now I'm going to start up 4 copies of this step at runtime. So I'm going to say times 4. Meaning I'm going to start up 4 writer copies to Cassandra. And what we will see then is that each of these copies will have that performance of 1,000 rows. So you can imagine combining various technologies, saying writing a MapReduce job that copies massive data from HDFS into Cassandra, for example. Not just in 1 or 2 copies, but maybe 100 mappers that do it at the same time. At the same time, converting, filtering data on the fly. So if you look at the throughput of this step now, it's up to 4,000 rows a second. After a while, it kind of picks up the speed of the slowest component. So it's 4 times faster than before. So this is what we refer to by saying we scale up, by allowing each step to run in a separate thread, and some steps into more than one thread. Any questions so far? It's getting warmer here. All right. So, excuse me.
Question about this adaptive data layer. How do you kind of abstract away the version differences with this? I didn't quite understand that part.
So as it applies to Pentaho data integration, our plugin system makes sure that we talk to other steps in exactly the same way. And this is a very simple algorithm. We read and we write rows of data between the steps. So this is a very simple. There's obviously blocking going on, and obviously the data links between the various steps, like in the storm topology, is interchangeable. But in general, it's a very simple way of doing things. For the steps themselves, the big data plugins, and especially in the case of Hadoop MapReduce, we did have to put another layer in between, because every release that Hadoop produced, and we're going back a couple of years already with this project, we had to drag in different libraries, take different APIs. And since our customers are running on Hadoop versions all the way back to the beginning and the very latest versions, we found ourselves in a position where we say, okay, we really do want to support that broad spectrum. So we only had one option, and is to create a compatibility layer in between. And that's what what the marketeers call the big data adaptation level, or layer, or whatever. But it's just an API, right? Just an interface. Any other questions on that? But we do think that since we already went through the pain of doing that, why not have some advertisements to other developers out there? During any kind of stage, you can click on a step and see the output of that data. So I know you can't really see very well, but we have a user column here, a hit count, a time stamp, and a page on which we had a hit. This is some kind of aggregated web update, and this is a UUID that we get. So if you want to see, I know this is not ideal, but I guess it's more geared towards presentations and not towards live demos. We have a booth at the conference, Pentaho booth, and we do have live demos there, which not only can show you data integration, but also the BI aspect of that. All right. So now that we pumped some data into Cassandra, and just to give you guys an idea, so we have support for basic configuration, Cassandra host, port, socket timeout, username, password, key space. For 5.0, we also have the column family, table to the right to, consistency level, commit batch size, batch insert timeout, sub batch size, unlock batch inserts, support for time to live, SQL version 3, and Thrift.io support. And you can also, with this button here, specify which SQL to execute before we insert the first row. So for example, if you want to create a new key space or verify that it exists, stuff like that, you can do that. But if you compare that to the previous version of our Cassandra output step, you can see that every release we're adding a lot of features, to the point where we had to split off the various projects like Mongo and Hadoop from into separate projects, because they grow so fast. Cassandra has been evolving at a rapid pace thanks to data stacks, I guess. But so we have to catch up with that, and so we're doing that because we have joint. Reading from Cassandra is basically, again, the same thing. We have a Cassandra input step And in here it's easier. So there's a select star from sessions, CQL. You can pretty much put any kind of CQL in there that produces an output set. And we will say, okay, let's just try a preview here. So it shows the first 1,000 rows, and you can work with that. So in this example, we're doing something specific. So we're writing this to a dummy step, which is actually nothing. So if you run this, it will not land the data anywhere in a database table, in a text file, nowhere. So what we did, we went to the settings of this transformation. There's a data services tab on the right, and we allow you to specify which step in the transformation acts as a data service. So this data service is called Cassandra, and it will act as a new virtual table for the SQL that I will fire off later on. To have this SQL, to be able to remotely fire off SQL, we need a server. Now we already have a couple of services in our portfolio. One is called Carte, another called the Data Integration Server in the Enterprise Edition. I have run a Carte server. Fired it up before you got in here. So what this will give you back is a set of services, in this case of Cassandra, with a description of the various column names, data types, the lengths, whatever. And this is how we can remotely see the table names. So how the JDBC driver that we created is capable of seeing which transformation and which steps expose transformations. All right. So what we want to do next is get a the most popular page on that website. So this SQL that we're going to fire off, it hits that server. The server is parsing that SQL, and it's going to see that, okay, we need to do a group by, we need to do a sort at the very end. Maybe if there's a where clause in there, we need to do a where clause. So what it's going to do, it's going to create, assemble, because it's just metadata for us, a new transformation on the fly. It's going to execute that Cassandra reading transformation. It's going to pipe the data into this transformation that created the SQL transformation, and it's going to give the data back. I'm going to hit the preview button. Oh, please. Yeah, it was a little bit too fast, but so it kind of went through 450,000+ records in that small instant. If we now go back to our status of our server status, we see that there is a service transformation. Here are Cassandra, and it's just 10,000 rows. That's fine. So it did 10,000 rows, and it also generated a SQL transformation on the fly. This is some transformation that got executed and generated on the fly, like I said. We can do these sorts of things because, again, the programming language that we use is metadata and not Java or something. So we can simply, based on that SQL, generate this sort of transformation. Any kind of questions so far?
Oh, one question.
Sure.
It's possible to create a transformation using different versions of Cassandra? Read from one version to another? It's possible.
Yeah. It's possible. Yeah, because our customers are using different versions, so we cannot say we're going to ship with a.
Do you know from which version it's compatible?
No. Sorry. Well, I can set you up with somebody who knows. Yeah.
Is there anything you need to deploy to a Cassandra or Hadoop cluster, either for performance improvement?
So the question
Is there anything you need to deploy to the Cassandra cluster or Hadoop cluster by default or to improve performance?
No. So in the case where, for example, you would want to write to Cassandra inside a MapReduce environment, right, in a mapper or a reducer, suppose that you're doing some kind of aggregation of incoming data every 15 minutes and push the aggregate result into Cassandra. Let's take that use case. So in that situation, you have to make sure that your big data plugin is deployed in the shared cache of Hadoop so that all the nodes know how to execute our software. This is done automatically by our software. So the first thing that you do when you execute a MapReduce job is to deploy plugins. You can also write your own plugins and specify it to have them deployed as well. So it's actually a very simple way of doing that. In other situations, yeah, storm topologies and stuff like that, we do need to make sure that we are in clustering exercises or in the old grid computing kind of situation. I have written a book, Pentaho Kettle Solutions, which actually goes more into detail about how you can, for example, set up an Amazon EC2 node with our software on it, packaged in, so that you can fire up, let's say, 20 or 30, and process a lot of data in parallel, stuff like that. So in those situations, you have to make sure that the big data plugin, which includes Cassandra input output, that one also gets packaged in there. Any other questions? Yeah.
So how is the mapping to storm cluster done? So is the workflow run inside single vault inside a storm cluster, or do you somehow define into which vaults the kind of workflow goes?
So Storm is not in production yet. So we have created a implementation which, unlike MapReduce, doesn't run snippets of transformation, but which runs every step in a different node, basically. So we're we're using the storm topology as much as possible. So we do look at what kind of step it is to see whether or not it's a spout or a bolt, or and we do haven't completely finished the work yet, because there are some strange things that you get, like sorting or grouping rows, for example, in that topology has a totally different meaning. It's like doing a group by in a reducer. You can never be guaranteed that you see the whole data set, so you can never assume that you do a group by over the whole data set. The same with Storm. So we're still tweaking that, but if you're interested, it's on GitHub as well.
And a follow-up question. So basically, I could calculate the sums in storm cluster and store just the sums. That would be an alternative implementation of your use case. And that would be more efficient. I would do the calculation in memory in storm.
Yeah.
Just put the results to Cassandra.
The use case for Storm might be to have, I think Storm is coming from Twitter or stuff like that, right? So big streaming situations. I think Cassandra is not a bad fit for that. So you could say that you're constantly parsing streams of data and constantly hitting Cassandra, for example, to present like a snapshot of the situation, or constantly putting the data in Cassandra. So that could be a use case. Yeah.
Last time we tried to use a PDI with Cassandra, it proved to be pretty useless because we couldn't specify any variables in SQL. Has that changed by now?
So let's take a look. I think it changed. So yeah, so you can't really see it, but we put like a small dollar. You need to check, the box, so that has changed. Absolutely. Again, this is an open source project. And Pentaho maintains this project for our customers, by our customers' needs, basically. But I do suggest that if you have feature requests, that you either go through our Jira case tracking tool and vote for an existing case, or just create a new one. And the way that Pentaho handles these requests is simply by prioritization. So our customers and our partners obviously get a higher priority. But all cases, also when they come from open source users, will get triaged every week and prioritized and scheduled for the next version. Where was I? Yeah. So the next steps for this driver, they are actually very interesting. So we do a release every 6 months at Pentaho. And the next thing that we want to do is precisely with variable support for CQL is allow that CQL to be generated and changed on the fly. And that allows us to do push-down optimization. 5 more minutes. That allows us to do push-down optimizations inside, for example, based on the SQL that the customer fires off, we can then change the CQL so that we can do especially filtering on the Cassandra cluster, or on the MongoDB cluster, or on the database itself. So push-down optimization is coming up next, as well as caching real time. So we're going to do more and more real-time use cases, particularly because of Storm and because of the need for more operational dashboarding. Okay. But this framework that we're presenting today, data blending, allowing this transformation, reading data from Cassandra to blend in data from MySQL, from any kind of data source that you want. We have a palette of 200 steps to do joins, various types of lookups, various types of scripting, anything you can imagine, regular expressions, 200 different types of operations that you can push in here. And any kind of data that I mentioned earlier, Cassandra and Mongo, Cassandra with a regular database, Excel files, text files, anything you can imagine. You can blend them now on the fly. My colleague has a very nice demo of at the booth of showing live tube situation. He gets that from a web service. He blends the data together and he shows like a nice report with colors in green and red and stuff like that. Any other questions? I know this is very short and condensed, but I can guarantee you if you download Pentaho Data Integration, I think most people will agree that you get up and running with this tool in a matter of hours or a day at most. All right. This is just what I had to show in a small amount of time. I hope that you see that this is not some black box that we created, that you can see everything going on, everything taking place, so that you can really tweak it to go like. All right. I think I have one more slide. The key takeaways. So we have a new simplified analytical experience, so you can watch that in the booth. We were proposing to use blended big data, sourcing directly to Cassandra for more accurate insights. And I would like to say they're also reducing the need to copy over massive amounts of data from one container into another, because that just sounds silly. And we're enterprise ready. We offer professional support services, you name it. Monthly patch releases, God knows what, if you need it. Okay. All right. Thank you very much. And again, apologies for the low resolution. Couldn't find a way around.